When we look at applications of Taylor series, we're going to start with binomial expansion. So we're going to say 1 plus x to the k power. Now, we've seen this all throughout. Let's say 1 plus x squared, and we know this to be 1 plus 2x plus x squared. And we could have 1 plus x to the third. Oops, let's put the third out here. So we have 1 plus, when you write them out, you multiply them, you get 1 plus 3x plus 3x squared plus x to the third. Now, I prefer Pascal's triangle, and I'm going to go into that in a bit. But let's look at the Taylor series expansion for that this morning. And this is going to be the series from n equals 0 to infinity of k choose n x to the n. K choose n is defined as the combinatorics k choose n, the combinations k choose n. So there's a button for that on your calculator. I'll show you that in a minute, probably. So we have k factorial over n factorial, k minus n factorial. That's the defined definition of we read this part right here as k choose n, and it's the combination. So that's the defined definition. But the Taylor series uses the definition of k, instead of saying k factorial, and we know that this k factorial right here and k minus n factorial are going to cancel somewhat based on definition of factorial. So let's look at the top. We have k times k minus 1 times k minus 2 times k minus 3 times k minus 4, all the way down to k minus n plus 1. And the next one would be k minus n factorial, which cancels with the k minus n factorial on the bottom. So we have all of those over n factorial, and the k minus n factorial on top canceled. So let me just clean it up a little bit and call it k times k minus 1 times k minus 2 dot 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 times k minus n plus 1 all over n factorial. Now, if I were doing this, I would use this on your calculator, and I'm okay with that. But if you'd like to write these out, you may. This is not something I'll require you to memorize. If you're in my class, I will make sure that you have this information if you need it. So both of these will work. So let's look at what this binomial expansion looks like then. So let's say we have 1 plus k to the 5th power. So using the Taylor series, which we could go back and look at. Hopefully you wrote it down. If not, pause, rewind, write it down. So we're going to look at the binomial expansion from n equals 0 to infinity. And our k is 5, choose n, x to the n. So this is not bad. You start off with 5 when n equals 0, so you have 5 choose 0, x to the 0, plus 5 choose 1, x to the first, plus 5 choose 2. Oh, I'm used to writing fractions, can you tell? So 5 choose 2, x squared, notice it's not a fraction, plus 5 choose 3, x to the third, plus 5 choose 4, x squared, x to the fourth, plus, we're going to do 5 choose 5, x to the fifth. Now I'm going to use the combinations formula, which says 5 choose n equals 5 factorial over n factorial, 5 minus n factorial. That 5 is whatever your k is, your power up here. So you can use this formula if you're doing the expansion using the Taylor series. So I have 5 factorial over 0 factorial, 5 factorial. 5 minus 0 is 5 factorial, x to the 0, plus 5 factorial over 1 factorial, 5 minus 1 is 4 factorial, x to the first, plus 5 factorial over 2 factorial, 5 minus 2 is 3 factorial, x squared, plus 5 factorial over 3 factorial, and 5 minus 3 is 2 factorial, x to the third, plus 5 factorial over 4 factorial, 5 minus 4 is 1 factorial, x to the fourth, plus 5 factorial over 5 factorial, and 5 minus 5 is 0 factorial, x to the fifth. Now, I like to cancel this in amazing ways, but I'm going to do it when when they use the formula, they cancel the one on the top with the factorial to the right because that's where that formula comes in. So I'm going to build it that way this time so you can see it. And then I'll probably back it up and show you how to do it easier if you're using this formula. So we have 5 factorial over, by the way, 0 factorial is defined to be the number 1. So I'm going to leave that off. And notice that these two 5 factorials cancel. So that's going to give us the number 1 right here. And x to the 0 is 1. So we're going to run with 1 right here. Plus, we have 5 factorial over 4 factorial. So that means the top is 5 times 4 times 3 times 2 times 1, and the bottom is 4 times 3 times 2 times 1. So that's just 5x plus, again, we're going to look at this one. So it's 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. So we have 5 times 4 on top and 2 factorial. I'm going to go ahead and write it 1 times 2, x squared. Nah, I think I'll leave it 2 factorial. It doesn't really matter. It's the same thing. Plus, now I really would like to cancel the 5 and the 3, but I'm going to follow in their pattern. So we have 5 times 4 times 3 because that cancels with the 2 factorial. We have 3 factorial on the bottom. But you can see how this builds the series and how the factorial in the denominator matches the power of the variable x. So that works out nicely for us. And the next one, we have 5 factorial canceling 1 factorial. So that means we keep 5 times 4 times 3 times 2 times 1 on the top. Oh, not the 1. 5 times 4 times 3 times 2. There we go. Not that it matters, but I got carried away. And it's over 4 factorial. And then we have 5 factorial over 5 factorial. So that's 5 times 4 times 3 times 2 times 1. Oh, I forgot my x to the 4th. Let me back that up. X to the 4th, and this one is x to the 5th. Yeah, be careful of all the little pieces. So then you have 1 plus 5x plus, now that's 20 over 2, which is 10x squared. And 5 times 4 times 3 is 60 over 6, x to the 3rd, plus 5 times 4 times 3 times 2 is 120 over 24, x to the 4th, plus 1, x to the 5th. So we have 1 plus 5x plus 10x squared plus 60 divided by 6 is 10x to the 3rd plus 120 divided by 24 is 5x to the 4th plus x to the 5th. So if you were to expand that by writing 5 of them and multiplying them out, this is 1 plus x to the 5th power using Taylor expansion to get it. Now you can do this 5 choose N on your calculator. K choose N is the button NCR on your calculator. So if you want to do, say, 5 choose 3, you would put 5, and then you're going to pick the NCR button. So you're going to hit the math button, and then go across the top to the PRB for probability. And partway down, you'll see that NCR, and you choose that, and then you pick the 3. And when you hit enter, it will tell you what 5 choose 3 is. Let's see, 5 choose 3, I think we got 10. So if you'd like to use your calculator there, I'm not opposed. If I were doing this, not the Taylor expansion way, but I wanted you to see that when you have this term here, let's say 5 choose 2, you can use the formulas they gave you earlier. It's just easier for me to use the combination formula because I know it. This formula here makes sense and is really where it comes from. They're just trying to make it easier for generalization purposes. If I were doing this not that way, I would cancel these 5s and 5s here and go straight for a 1 right off of there because 0 factorial is 1, so everything cancels to be 1. And for this one, I would cancel the 5 factorial over the 4 factorial to just be the number 5. So I would cancel it differently if I wasn't trying to show you these numbers on the top and where they came in. But this 1 plus x to the 5th power right here, this is your binomial expansion. But I would like for you to see one more. So let's look at one more. Okay, so let's look at 1 minus 3x squared to the 4th power. Why not? Now we know that 1 plus x raised, all of the whole binomial raised to the k power is the series from n equals 0 to infinity, k choose n, x to the n. So what we're going to do is we're going to say that 1 minus 3x squared to the fourth power is the series from n equals 0 to infinity. Now our k is 4, and it's not a line, it's not a fraction, it's a choose. It's a habit that I have. 4 choose n. And then instead of x, we have negative 3x squared to the nth power. So let's build this. We're going to start with 4 choose 0 when n equals 0. And then we have negative 3x squared to the 0 power plus 4 choose 1, negative 3x squared to the first power plus 4 choose 2, negative 3x squared to the second power plus 4 choose 3, negative 3x squared to the third power plus 4 choose 4, negative 3x squared to the to the fourth power. Got carried away. All right, let's think about 4 choose 0. 4 choose 0 means 4 factorial over 0 factorial, 4 factorial. I'm using k choose 4. Let's put a 4 here. I'm going to use my combinations formula. 4 choose n equals, let's put it in a different color so it doesn't blend in too much, equals 4 factorial over n factorial, 4 minus n factorial. And then anything to the 0 power is the number 1. So we're just going to say plus. 4 choose 1 will be 4 factorial over 1 factorial. 4 minus 1 is 3 factorial. And then we have negative 3x squared to the first. I'm going to line them up. So I have 4 factorial for 4 choose 2. I have 4 factorial over 2 factorial, and 4 minus 2 is 2 factorial. Negative 3x squared squared. Negative 3x squared squared. Negative 3 squared is 9, and x squared is x to the fourth. So let's go ahead and throw that in there. Plus 4 factorial over 3 factorial. 4 minus 3 is 1 factorial. Negative 3 to the third is negative 27. X squared to the third is x to the sixth. Plus 4 choose 4 is 4 factorial over 4 factorial, and 4 minus 4 is 0 factorial. That's the number 1. Let's cross it off up here as well. Negative 3 to the fourth is positive 81, and x squared to the fourth is x to the eighth. So now let's clean it up a little bit. All of these cancel to be 1, which makes sense because our leading term is 1, and no matter how many of these parentheses you have, you end up with 1. And 4 factorial over 3 factorial is the number 4 times negative 3x squared. And then this 4 factorial and 2 factorial becomes 4 times 3 divided by 2 is 6 times 9x to the fourth. 4 factorial over 3 factorial is the number 4 times negative 27x to the sixth. And then these cancel to be 1, so we have 81x to the eighth. So now we can finish it off and have 1 minus 12x squared plus 54x to the fourth. Oh, that's not a plus, so 4 times 27, that's minus 108 x to the sixth plus 81 x to the eighth. So it's not too hard to use Taylor's series to do your binomial expansion. If you have to do it on test, make sure that you show the series work and not just do that. I do love Pascal's triangle, and I am a fan of that over this, but it works either way. Make sure you can do it if you need to, and let me know if you have any questions.